Okay, in part two, we are going to find the surface area of a cone. And just like before, we're going to unwrap this thing. So if you imagine like a like those birthday hats, those are a cone, except of course this one has a base that we'd still have to find the area of. So imagine that we unwrap this. So I found this video and I'm gonna kind of play around with this video real quick. So let's see if I can get to it pretty easily. So here's this video. So imagine, look at the cone at the right. Okay, so we have this cone right now, and notice it doesn't have a bottom right now. But what we're going to do is we're going to unwind it. Notice what happens when we unwind it, right? We get what's called a sector. And if you notice that whole bottom part, that whole like semicircle, it's not a full half circle, but that whole semicircle, what does that represent? Well, if you kind of look back, right, that semicircle is just the circumference of the original circle, right? If you look at the base, so when I wind, look at that base, that base of the circle, when we unwind it, we get this, it's not quite far enough, we get this sector, and we get that bottom, right, which we call an arc, and that length of that arc is the circumference of the circle. Okay, so keep that in mind. And let's go back to our notes. So what we want to do is we want to go and find this. So I'm going to do my best, and this is not going to be the greatest drawing, so hopefully please stick with me. I'm going to unwrap this thing. So first off, when we unwrap this thing, we break this up into two pieces like usual. We have our base, which maybe is a little big. Let's see if I can shrink that base a little bit. Okay, so there's our base. Now remember, that's the base of this thing. So that right there is just this bottom part right there, right? And that base, I think you'd agree, has a radius of r. So its area is really easy. Now, let's talk about the lateral area. So that lateral area, right, is the area of a circle. So let's just kind of imagine it for a second. It's the area of a circle, but it's not the whole circle, is it? Right? There's like a chunk taken out, and this circle may be a little bit big. So let's take a chunk out of the circle. So maybe this circle looks something like, right? So kind of looks something maybe like that. I don't know exactly what it looks like, but that's probably pretty good. So it's, whoops, that's too big. So it's this sector right here. Okay, and I want to remind you, this sector right here, this piece right here, let's do this in orange. This right here, that arc, that length of the arc is exactly the same as the circumference of this circle. Okay, so let's keep that in mind because that's an important connection between the little circle and the sector. So let's see what we can do to develop this. And this is going to be this development's going to maybe be a little bit harder, but let's see what we can do. So the first thing I do is I think you'd agree, I want to find the surface area. I'm just going to work, obviously the base is easy. So I want to find the surface area of that lateral side. So I'm going to say, just like usual, I'm going to write a proportion. So this is the lateral area. We don't know what that is, okay? So we have the lateral area, but I think you'd agree it represents a fraction of the circle. So that the lateral area is to the area. I'm going to call this, just for our notes, this is going to be circle C. Okay? So it's going to be equal to, it's over the area of circle. That's a symbol for a circle, circle C. So what I'm saying is this is a ratio, right? So the shaded part is to the entire area of the circle, and this is why that circumference is so important, as the arc length, right? So this right here, that arc length is to the entire circumference of the circle. So, right, is to this entire thing if we had that entire circle. So, circumference, however you spell that, circumference, F-E-R-E-N-C-E, of circle C. Okay? So, I'm setting up this ratio. That's all I've done. I've said, hey, look, the area of the sector, right? This slice of this circle, the area of this slice of the circle is to the area of the entire circle as the area of the arc length is to the entire circumference of that big circle. So what we want to do is find that lateral area, right? So I think you'd agree, if I want to find that lateral area, I'm going to multiply both sides by the area of the circle, of the big circle, to move it over to the other side. So what I end up with is I'm going to say the lateral area equals, and this is what we want to find, right? This is exactly what we're looking for right here. What does that equal? That equals the arc length, which we don't know yet, arc length. I think you spell arc with a C-H. I think it's arc. Yeah, I think there's an H there. Not that it's a big deal, but I think it's A-R-C-H. Arc length is to circumference of circle. I'm going to abbreviate times, right? Because we multiplied by the area of the circle. Okay, now we got to plug some things in. So remember what we said before. Let's see if we can plug some stuff in here. We said that the arc length, that pink part, right? This part, actually, let me show it here. This piece right here, that arc length, we said it equals the circumference of the circle, right? So what is this? What is the circumference of that circle? Well, that circumference of the circle is 2 pi r. Now, that we said is, that's our arc length, and then we have to find the circumference of the big circle. Well, notice, and this is kind of, I probably could have indicated this earlier, but this length from, let's use our pointer. This length from here to here, if you go back, when we unwound it, this was our L. Okay? So in other words, that is our slant height. And I'm going to just kind of go back to that video really quickly to make sure that you see that that actually is the length of L. So let's kind of go back there real quickly, right? So when we, here's our thing. So that line that's going down on the right-hand side, right? That's our lateral height. And when we unwind this thing, right? That radius of that sector. So I can't draw on here because it's a picture or a video, but that radius is L. So going back to our thing, hopefully that makes sense. So the circumference of our circle is, of the big circle, is 2 pi r L, right? It is 2 pi r L. Oh, sorry, not 2 pi r L, it is 2 pi L, because I don't know why I'm saying R. It's 2 pi L because the radius is L. So excuse that R. There is no R in that one because our radius in this case is L. And the circumference of a circle is 2 pi L. Then we have to multiply it by the area of the circle, right? And the area of a circle is pi r squared. So that is pi, but R in this case again is L, so that is L squared. Okay. Let's see what we can do from there. So simplifying this, okay, let's see here. Let's do some canceling out. So there's 2 on top, there's a pi on top. Oh, look, there's an L squared here and an L on bottom. So I'm going to cross out that L and I'm going to cross out that squared. So we are left with, when we are finished, we are left with r pi L equaling the lateral area of our, whoops, I'm trying to grab this. That equals the lateral area of our cone. But of course, if we want to find the total surface area, so our surface area of the cone equals, well, it's going to be the lateral area. So r, actually, let's put this nicer. Let's put it pi r L, again, where L is the slant height of the cone, plus the base, which is just a circle, right? It is this circle right here, which is pi r squared. So plus pi r squared. Okay, and that's our surface area of our cone. So let's put this all together. Let's go and do an example. So here's our example. And let's see what we have in this case. In this case, and I want to make sure you understand, we have a cone and we know its height. The height of this cone is 8 units. That's not the lateral. That's not the slant height, right? That slant height, we don't know it yet. We just know the height of the cone. So the slant height is going to be this height right here. But I think you would agree that that slant height, we can find it by using Pythagoras' theorem. So that slant height, which we'll call L, so is going to be equal to 8 squared plus 6 squared is going to be equal to that slant height squared. When we solve that, we're going to get L equals 10. Okay, so now let's put this together. So let's find our lateral area. So the lateral area, we said was pi r L, where L is the slant height. So that's going to be equal to pi. The radius is 6 and the slant height is 10. So our total is 60 pi. And our units, notice, is centimeters, so it is centimeters squared. Then, of course, we have to add the base. So our base has a radius of 6 and it's a circle, so it's equal to pi 6 squared, which is 36 pi centimeters squared. So our total is going to be equal to our lateral area plus our base. So that's going to be equal to 60 pi plus 36 pi centimeters squared, which I think you'd agree is a total of 96 pi centimeters squared. Okay, and that's how you find the surface area of a cone.